Woohoo, we're back. Today we're going to be talking about a very special kind of sequence called an arithmetic sequence, which brings up the point that I learned to say arithmetic instead of arithmetic. And so when you're talking about a sequence, I was told to pronounce it arithmetic. So I don't know if that's actually correct, but we'll go with it. And I apologize if it's just a little on the weird side. But, you know, my squirrel friend tells me, don't apologize for being weird. Embrace the uniqueness. So that's where we're going to go with it. So, arithmetic sequences. The simplest way to generate a sequence is to start with a number A and add a fixed constant D over and over again. So this is the easiest way to come up with a sequence other than just a list of random numbers. So this is probably the easiest pattern to follow. So what is our example? Our example is we start with 3, and then we add 1. 3 plus 1 is 4. And then we take the 3 plus 1 from the previous, and we add 1, and we get 5. And then we take the previous 3 plus 2 now, and add 1 and get 6. And so on and so forth. So our actual sequence will look like 3, 4, 5, 6, 7, 8, etc. So each time we're just adding 1. If you're starting with a constant and adding any amount, really, you can add or subtract, but you add or subtract the same amount to get to the next term. This is an arithmetic sequence. And so the first question is, what is the nth term? So let's take a look. The first term has 3 plus 0, right? So a sub 1 is actually 3 plus 0. A sub 2 is 3 plus 1. A sub 3 is 3 plus 2. And as I note here, I see that I am adding, so the fourth term is 3 plus 3. I'm adding 1 less than this counter number, than the subscript. So I think my guess is going to be that the nth term would be, you start with 3, because they all start with 3, and then you add 1 less than your term number. And in fact, the formula that we're about to go over says it's actually 3 plus 1 times the quantity n minus 1. Okay, so let's look in general what's going on with these. Arithmetic sequences. In an arithmetic sequence, the number A is the first term, so there's our first term, and D is the common difference between terms of the sequence. And honestly, a lot of times it feels more comfortable to write the D in front of the n minus 1, so you can go ahead and do it either way. In our case, in the previous problem, our D was 1. That was how much we're adding every time, the common difference. So, for these problems, let's practice. We're supposed to find the common difference, the first 6 terms, the nth term, and the 100th term. Dun, dun, dun! But this is, again, all we're doing is we're building up our understanding of patterns. And this is what we want to look for. What kind of patterns? Because out in the wilds of mathematics, nobody's going to say, oh, look, that's an arithmetic sequence. You're going to be asked to recognize it. So what steps do you go through? Well, if you see a sequence and you realize you don't really recognize, like there's no obvious pattern to me, a couple of the numbers do seem like they look like Fibonacci, but it doesn't stick. So, okay, it's not really Fibonacci. And if you don't see anything else obvious, the next thing you should do is look at how the sequence is changing. So I'm going to look from 2 to 5, I'm adding 3, from 5 to 8, wait a minute, I'm adding 3 again. From 8 to 11, there we go. Holy cow. If you add the same amount every time or subtract it, it's an arithmetic sequence. It is, in fact, arithmetic. And in fact, we've got this great formula that tells us how to build the sequence. But before we get there, I don't want to get ahead of myself. 2, 5, 8, 11. Okay, now I need to get to 6 terms. 1, 2, 3. That's 4 terms. Plus 3 is 14. Plus 3 is 17. So those are the first 6 terms. The nth term, an, again, following one of these two formulas, whichever one makes the most sense, I'm starting with, let me underline the 2, the a. This is my a. That first term is going to be my a. That's 2 plus, and then the common difference is going to be this number, that 3. So that's going to be 3, oops, need my yellow. That's going to be my 3 times n minus 1, or so you could write it either way. And then what is the 100th term? So a sub 100 is going to be 2 plus 3 times 100 minus 1. So that's going to be 2 plus 3 times 99, which is 2 plus. Now, 3 times 99 is a lot to multiply, but 3 times 100 is 300. 3 times 99, 99 is 1 less, so it's 1 times 3 less than 300, or 297, and that's 299. Woohoo. Okay, here we go. We got the common difference, so my d equals 3, the first 6 terms, the nth term, and the 100th term. We're done, yay! Let's do it again. Woohoo! Now this one's kind of interesting. This one gets smaller. So again, if you're out in the wilds and you're just find this sequence, if there isn't obviously a pattern, and in my mind, I don't see a pattern here necessarily, how do I get from 13 to 7? Well, I subtract 6. How do I get from 7 to 1? Ooh boy, I subtract 6. From 1 to negative 5, I subtract 6. So my common difference is, in fact, negative 6. Okay, what are the first 6 terms? 13, 7, 1, negative 5. Now, I got to subtract 6 again, negative 11. Subtract 6 again, negative 17. Okay, nth term. A sub n equals my starting point. There's my blue starting point. That's going to be 13. And then plus, and then here, my common difference is going to be negative 6 times n minus 1. And that formula is always going to be true, because why is it n minus 1? Well, again, at the starting point, you just start with the 13. There is no negative 6. Negative 6 only starts in after the second term. So it's n minus 1 because you don't start right off at 1. Okay, now this is not nice. So depending on how you want to write it, it could look like this. If someone wants you to write it very formally, it could look like this. Or it could look like that. Okay, and then what's the 100th term? And here, again, we're just going to use the formula. 13 minus 6 times 100 minus 1. It's going to be 13 minus 6 times 99. Now, again, you can use a calculator, or you can think to yourself, this would be right here, just 6 times 100 is 600. 6 times 99 is 1 set of 6 less than that. So 600 minus 6 is 594. Woohoo. You can always do this on your calculator. So if we listed out 100 of these, we'd get to negative 581. Woohoo. Okay. Woohoo, woohoo. Shall we move on to the next page? Now, this gets interesting. I can give you some information and then tell you to figure out the rest of it. So, in this case, I know that the 11th term, so a sub 11, is 52. And I know that the 19th term, A19, is 92. Okay, and what is the 100th term? So, this one is actually pretty cool. If by pretty cool you mean you have to set up a system of 2 equations and solve. Woohoo! Yay! Party time! So let's take a look. A sub n is, by definition, a plus d times n minus 1, right? That's our definition. We're told this is an arithmetic sequence, so we know that this is true. So a sub 11 is a plus d times 11 minus 1. So that's a plus 10d. A sub 19 is a plus d times 19 minus 1, which is a plus 18d. Now we know that a sub 11 is 52. We know that a sub 19 is 92. Looks like I got 2 variables, 2 equations. I got a 2 by 2. So what are our options? Well, you got a ton. You want to set up an augmented matrix? Go for it. You want to solve this using regular old elimination? Go for it. Gaussian elimination? Go for it. You want to use Cramer's rule? Go for it. In my mind, I've got a plus 10d equals 52. A plus 18d equals 92. I'm going to go old school. I'm going to go ahead and multiply by a negative 1 up here. The opposite of a minus 10d equals negative 52. Those of you who are using Cramer's rule, you're done by now, right? Yeah. So this is not the fastest way, but I'm the old school. I end up with 8d equals 40, it looks like. So d equals 5. Right? System of equations. And then if d equals 5, then I can go back to a plus 10d equals 52. So then if d equals 5, a plus 10 times 5 equals 52. A plus 50 equals 52. So a equals 2. Oops, sorry, you can't see that. So a equals 2, d equals 5. Let's check. I'm going to check the other one. A plus 18d equals 92, my second equation. 2 plus 18 times 5, does that equal 92? So that's 2 plus 90. Yep. So, what were we supposed to do? We're supposed to find the 100th term. Okay, so I know that a sub n is a plus d times n minus 1, right? So let me scooch this a little bit. So I'm going to bring us here. I'm going to bring us there. So hopefully it's a little bit easier to follow. So a sub n equals 2, right? Because a was 2, plus d is 5. And you can double check it, right? We know the 11th should be 52 and the 19th should be 92. So you could always quadruple check this. but I want to know a sub 100. That's 2 plus 5 times 100 minus 1. That's 2 plus 5 times 99. 5 times 99 is 500 minus 5. So that's 495. So pretty cool problem, right? You just step through it. Anytime you're given two answers, that should light up the whole system of equations part of your brain. So we got it. The 100th term is 497. Ha 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 ha. Okay, now I want to do something a little bit theory heavy. You guys ready? Yes. Good. Dun dun dun. Partial sums of arithmetic sequences. Okay, so we're going to take a deep breath. This is going to be very formal, but I believe in you. The nth partial sum of an arithmetic sequence is, let's take a look at this. Partial sum, summation of, from k equals 1 to n, a plus n minus 1 times d. Right, so it's a plus d, a plus 2d, a plus 3d, right? Because you're adding d every time. Okay. Now, if you look at this, you got a bunch of a's and a bunch of d's running around, right? Gauss, you know, good old Gauss, Gaussian elimination, all that fun stuff. He gave us a nifty way of adding a bunch of terms together. You guys ready? It's kind of cool. So basically, if you want to add up, so we're saying, you know, take a pause here. If you want to add up what happens from k equals 1 to 20 of k, right? So 1 plus 2 plus 3 plus 4 plus 5, etc. Okay. We're going to take that and write it out twice. So what the heck are we doing? I wrote 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, etc., 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 plus 18 plus 19 plus 20. And then I wrote it backwards, 20 plus 19 plus 18, because we are allowed to add in any order we like. And then we write them next to each other, and then we notice. The 20 and the 1 match up. The 2 and the 19 match up. The 3 and the 18 match up. The 3 and the 18 match up on the other side. The 2 and the 19 match up here, and the 20 and the 1 match up. So what we get is a bunch of 21s. Huh. How many of these will there be? Well, we know how many there will be. There's one here, a second one here, a third one here, 18, 19, 20. There are 20. So right here, we've got 20 21s. Right? So this is kind of cool. And this is a technique that we use in math all over the place. Pardon me, squirrel. Okay, so twice this, because we can line them all up, is 20 times 21. So S20 is 20 times 21 times 1/2. So adding the 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus etc. 18 plus 19 plus 20, we just have to multiply 20 times 21 and then take half of that, which is pretty cool. Now, some people are like, well, what if we get a fraction? That wouldn't make any sense. Well, take a look here. Either 20 is even, and then you can divide by 2 and not get a fraction. Or if we'd started with an odd number, we would still be able to, the next number, so if this had been 21, this would be 22, and that would be divisible by 2. So one of them is divisible by 2. Okay. So this is a big deal. This is a massive, massive result in mathematics. The partial sum of the first 20 integers, no, 20 natural numbers, 1 plus 2 plus 3 plus, etc., plus 18 plus 19 plus 20. And you can check this. Is equal to 20 times 21 all over 2. So that's 210. And you can check this. And in fact, if we add all the way up to n, so in other words, 1 plus 2 plus 3 plus plus n minus 1 plus n, if we add all the way up to n, we get n times n plus 1 all over 2. And so that is the sum of the first n natural numbers. And this is something you want to tuck away somewhere really important, because this comes up all the time in math. How do we add these all together without having to pull out a calculator and going 1 plus 2 plus 3? This is the formula. The last number times a number one bigger, so 20 times 21 divided by 2. Okay. So, using the same method, we can find the partial sum for the first n terms of an arithmetic sequence. So remember, I started this section out, I said the nth partial sum is a plus d plus a plus 2d plus da-da-da-da-da, and I said, oh my goodness, what are we going to do? And the answer is that if we have a plus n minus 1 times d, so that's each term, the nth term, then the partial sum is just n times the first term plus whatever that last term is divided by 2. And that has to do with, and I'm leaving out some magic. So magie happens, a little bit of math, which I'm not showing you, but if you would like to ask me, I am happy to show you how this all works. I'm just not going to take the time right now because I'm not sure a lot of people would find it that interesting, but I'm happy to show you how it all works out. But basically the partial sum for an arithmetic sequence. So find the sum of the first 300 odd numbers. So can we just use the simple formula? This one is so easy. No. This one is 1 plus 2 plus 3 plus 4. It has to be that order, and then you get that as the total. What is this asking for? This is asking for the first 300 odd numbers. So this is 1 plus 3 plus 5 plus 7. So you're skipping, right? So first off, let's figure out what this arithmetic sequence is. What is our difference? Our difference is 2. This is always surprising for people. They think of when you're getting to odd numbers, you must be adding an odd number. And the answer is no. You're adding 2 because we're jumping over a number. We're jumping over the even number, so we're adding 2. So this is an arithmetic sequence. We start with 1, right? That's our blue. Our blue was 1. And then our difference, in yellow, is 2, and so we're going to get 2 times n minus 1. So this is our formula for our arithmetic sequence. This is odd numbers. Now, if I want to find the sum of the first 300 odd numbers. So I want to know 300, the sum of the first 300. So I want A1 plus A2 plus A3 plus dot 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 plus A299 plus A300. So I want a bunch of them. Now, how big a pain would this be to calculate on your calculator? Oh my goodness, such a pain. This would be, you could do it. You would be up for a little bit doing it, right? Because this is 1 plus 3 plus 7, or 5 plus 7 plus 9 plus 11 plus 13, etc., etc., etc. So the first question is, What is A300? What is that last term that we're interested in? Is it just 301? Is it 600? What is the number? So let's take a look. A300 is equal to 1 plus 2 times 300 minus 1, right? So that's 1 plus 2 times 299. And again, in the same way, I'm probably actually going to multiply 2 times 300 is 600 minus 2. So this is 1 plus 598. So this is 599. So we want to know the sum of the first 300 odd numbers for whatever reason. 1 plus 3 plus 5 plus dot 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 plus 597 plus 599. We want to know what that sum is. And so what do we need to know? We need to know, and this is just for an arithmetic, this is the partial sum of an arithmetic sequence. Okay, so I am S300, oops, you can't see. Can I get them both in? Kind of. Is equal to 300 times A, that's that first number, 1, plus A300 all over 2. So it's really interesting because it's almost like you're taking an average of the first one and the last one, right? You're adding those two together and dividing by 2, which I think is kind of cool. Okay, so that's 300 times A happens to be 1. A300 is 599. So that's 300 times 600 all over 2. Ooch, scooch. Which is 300 times 300, which is 9 with 4 zeros. So you would have been up a really long time adding those all together. Woohoo. So that's arithmetic sequences. There's a bunch of things we can do. There are a bunch of cool patterns. I hope you geek out on the homework. Definitely ask for help if you need some. Take a break. Shake out the old Etch-a-Sketch because the next section is going to be geometric sequences. They are related but really different. So what you want to do is really focus on this. So I'd recommend make sure you understand this. Do this homework first. Then go on to watch the videos for 8.3 because the two of them they're not going to play well. They are not going to play well. They're both going to be running with scissors around the pool. You know it. So get a good break, though. Speaking of which, go swimming if you can. Oh, my God, that would be amazing. And you're amazing, and you're incredible, and you're very, very smart, and I really appreciate it. So I hope you have an amazing day, afternoon, night, evening, whatever it is. I hope you're having a great one, and if not, I hope tomorrow is even better. And, woohoo, and math on.